Hey guys, welcome back to my channel. As requested by all of you, I'm making this video about things you need to know for Paper 2 IGCSE Cambridge Maths. This is the non-calculator paper. This video is also going to be useful for kids who are appearing for O-Level Maths Paper 1. So basically, in this video, we'll discuss every single skill you need to know to solve questions without using the calculator. Everything that you will come across in this video, you have learned it before in your previous years, but obviously since you guys never practiced it like constantly, that's why you forgot them. And since now like you're more dependent on calculators, so your mental maths has weakened because of that. So with the help of this video, I'm going to show you some tips and tricks for each topic that has a higher chance of coming in paper 2 and how you can use those skills to solve these questions easily without wasting time. So let's start with the first one. So first question is on indices. So for these type of questions, you need to know what your basic square and cube numbers are. The reason why we need to know what the basic and square cube numbers are because we have to make sure that all of the bases, base being this part. So if we have 9 to the power of x plus 4, 9 is your base and x plus 4 is your power. So for these type of questions, we need to convert all of the bases into the same base, which is the prime factor base, and that's 3. 3 is a prime factor. So we know 9 is 3 square. So we can easily rewrite 9 as 3 square, and then all of the numbers have the same base. Similarly, anything to the power of 0 equals to 1, which means 1 is 3 to the power of 0. So things like this are very important, and in indices, you need to know these things. Because indices mostly uses like what a square number is, what a cube number is like. Because for indices, you will be frequently asked like you have to rewrite 8 as 2 to the power of something. 8 is what? 2 cube. So you need to know your basic square and cube numbers, your square roots, like at least till 11 and 12. So from 0 to 12, you need to know your basic square and cube numbers. For the cube numbers, you can know till like 7. But for square, you need to know till 12 at least. If you don't know them, then you need to memorize them now and they're not even that hard. Like you've learned them before. So if you just look at them like frequently, you will remember them. So that's the first thing you need to know for your indices questions. Then moving on, rationalizing the denominator. For this, you need to know that when you multiply the surd to itself, it's the same as square of root 2 in this case. When you multiply root 2 to root 2, it's square of root 2. It's exactly like 2 times 2, which is 2 square. So root 2 times root 2 is root 2 squared. So when you have a root, the root represents the power of 1 over 2. So as you have seen from the indices video that I already uploaded, when there's a power inside the bracket and outside the bracket, you multiply them. So 1 over 2 times 2 is 1. Now, in this question, you can also learn how to multiply a fraction with a whole number. When you're multiplying a fraction with a whole number, the whole number gets multiplied to the numerator, not to the denominator. It gets divided by the denominator but multiplied by the numerator. So you can either just do 2 divided by 2, or you do 2 times 1 and then again 2 divided by 2, which is going to give you 1. So this is another thing you need to remember. And this is a part of fractions as well. And also, if you get a question about like multiplying a fraction with a fraction or a fraction of the whole number, it's best that you simplify it. And simplification in a fraction can only be done vertically or diagonally. Horizontally, you can only multiply, not simplify them. So let's move on to the next thing. Now, your exact trig values. You need to know what your exact trig values are. For this, you can just memorize the special triangle. So if I draw a special triangle over here, this is the 30 to 60 to 90-degree ratio triangle. So one angle is going to be 30, one is going to be 90, and one is going to be 60. The length opposite to 30 degrees, let's assume that's 1. So if the length opposite to 30 degrees is 1, the one opposite to 90 is going to be twice of that. So that's 2. And the length opposite to 60 degrees is going to be root 3. This is your special triangle for the 30, 60, 90-degree ratio. So now looking at this, we know that if we're looking at 60 degrees, okay, that's our reference angle. So this is going to be our adjacent, this is going to be our opposite, and this is going to be our hypotenuse. So if the 60 degrees angle is the reference angle, sine 60 is going to be opposite over hypotenuse, which is root 3 over 2. Cos 60 is going to be 1 over 2, adjacent over hypotenuse, and tan 60 is going to be root 3 over 1. Similarly, if 30 degrees is our reference angle, then sine 30 is going to be, now this becomes your opposite, this becomes your adjacent, and hypotenuse remains the same. So now it's going to be 1 over 2. Cos 30 is going to be root 3 over 2. And now tan 30 is going to be 1 over root 3. Now looking at the question says solve tan x equals to negative 1 over root 3 for values of x between 0 and 360. Now over here we're getting positive 1 over root 3. But if you draw your 4 quadrants, this is your first quadrant, this is your second quadrant, this is your third, and this is your fourth. In the first quadrant, all are positive. Sine, cos, tan, all three. In the second quadrant, only sine is positive. In the third, only tan is positive. And the fourth, only cos is positive. Over here, our tan x is equal to negative 1 over root 3. So we've already figured out that is the 30, 60, 90 ratio because that gives us 1 over root 3. But for negative 1 over root 3, that means our triangle is in the second quadrant. Because in the second quadrant, tan is negative. It can also be in the fourth quadrant because that's where tan is negative as well. So if we draw the triangle over here and over here, 1 over root 3 is when the angle is 30. So this is 30. And this is also 30. So your one angle is going to be 180 minus 30 and the other is going to be 360 minus 30. If you did not know this about trigonometry, you wouldn't be able to solve this question. So x is 180 minus 30 and x is 360 minus 30, which is 150 and 330. You need to know where sine, cos, tan are positive and negative. If we don't know that, you cannot solve this question easily. Even if you know the special triangle, you'll figure out the angle. But there's a very high chance you don't figure out the right angle because if it's positive, okay, then you can say that it's in the first quadrant and the third quadrant. But for negative, it's going to be in the second and the fourth quadrant. Same applies for sine and cos. You need to apply your special triangle first, and then after that, you need to see in which quadrant what is positive, what is negative, and then on the basis of that, you find your angle. And the angle is always measured from 0 in the anti-clockwise direction towards the line that has the reference angle. So that's why this was the first angle and that was the other angle. And while we're talking about this, the second special triangle is the 45, 45, 90 ratio one. So this is 45, this is 45. This is an isosceles right angle triangle. So the lengths opposite to 45 and 45 are going to be 1. And the one opposite to 90 in this case is going to be root 2. So this is your other special triangle. For these type of questions, for the exact value of trig ratios, you need to remember your special triangles, like memorize them. Then next thing, again, it's the same type of question. Solve the equation 2 cos x plus root 3. So again, first make cos x the subject. So that's negative root 3 over 2. We take root 3 to the other side. When you take it to the other side, it will change its sign. Initially, it's positive. Now it's going to be negative. Similarly, 2 cos x is equal to negative root 3 now. So when you take 2 to the other side, it divides negative root 3, not times. Because originally it was multiplying cos x, but now it's going to divide negative root 3. So looking at a special triangle again, we saw that cos 30 is root 3 over 2. But now again we have negative. So if we draw the grid, we know that cos is going to be negative in the second quadrant and the third one. So 30 again over here and 30 again over here. And the fourth quadrant, you subtract the angle from 360. That is how you find the angle for each quadrant. So this was for trigonometry. Then factorization. For factorization, you need to know all three methods. Finding the highest common factor to simplify an expression, difference of perfect squares, and factor by grouping, along with factorizing a quadratic equation, 4 methods actually. So when you have two squares being subtracted, it's difference of perfect squares. Whenever you see two terms being subtracted and their square numbers, be it a variable or a number, it's difference of perfect squares. So a square minus b square equals to a plus b times a minus b. This is the rule you need to memorize. X square minus 64 will become x minus 8 because 64 is 8 square and x plus 8. So first method you need to know for algebra, factorization is difference of perfect squares. Then identifying the highest common factor. For this, look at your equation. We can clearly see that there is x minus 2y common between 5x and 6. So we take x minus 2y common, and that leaves 5x plus 6 times x minus 2y in the second bracket. Whatever is left behind, that always goes in the second bracket. So now we're going to expand the bracket in the second one. That's 5x plus 6 minus 12y. Then you're going to collect the like terms. When I talk about collecting the like terms, your variables always get added or subtracted the variables, and we have to make sure that they're the same variables. Like we cannot, do 6x minus 12y because x is a different variable and y is a different variable. So always identify your like terms, which are the same variables. Constants get combined with the constants. If there's a y, it will get combined with y. If there's an x, it goes with the x. So you have to identify your like terms and then collect the like terms when simplifying the expression. That's 11x minus 12y. You cannot further simplify. This is your simplified answer. So far, we've revised two methods for factorizing in algebra. Then the next thing is your rules of indices. You have to memorize your rules of indices. I've already covered them in the indices video, but I'll still go through it again. Your rules of indices state that when you have similar bases being multiplied, you add the powers. Base remains the same, the power gets added. Then if they're being divided, you subtract the powers. If there's a power inside the bracket and outside the bracket, you multiply the powers. Anything to the power of 0 is 1, whether a numerical value or a variable, fraction, anything. If it's raised to the power of 0, it will equal to 1. Then a to the power of any negative number, whether it's a whole number or a fraction, can be rewritten as a positive power by taking reciprocal of the base, not the power, the base. And reciprocal is flipping a term. Like, for example, if they ask us to find the reciprocal of 2, that's going to be 1 over 2. The reciprocal of 3 over 2 is going to be 2 over 3. Every whole number has a denominator of 1. Whether it's written or not written, you need to assume that it has a denominator of 1. So 2 over 1 becomes 1 over 2 when we take the reciprocal of that. So for reciprocal, you always flip the fraction. So when you have a negative power, you flip the base, it becomes 1 over the base, and the power is going to be positive then. And again over here, for us to simplify it, you need to remember your square and cube numbers. 16 is 2 to the power 4 or 4 square. So you have to use either one of these to simplify it. If you don't know this, then you won't be able to simplify the question and score these easy 2 marks. So square cube numbers are very important. Like they can be used anywhere in any question. Then negative integers. So you need to know when you're subtracting two negative integers. Let's say I'm doing -4 minus -12. So this bracket represents multiplication. So negative times negative is always positive. So first you simplify the bracket part, and then 12 minus 4 is going to be 8. Let's say it was 4 minus 12. Now you're taking away a big number from a small number. So answer would be -8. You can just subtract them normally, but for the sign of the bigger number comes. Bigger number numerically is 12. So 4 minus 12 is -8. For multiplication, if you're multiplying a negative integer to a negative integer, that gives a positive answer. So -3 times -3 would be +9. But if you're doing -3 times +3, that's going to be -9. So when you multiply a positive and a negative integer, that gives a negative value. When you multiply a negative and negative integer, that gives a positive value. And for addition subtraction, your answer will always have the sign of the bigger number. So that's why it's -8 over here and it's +8 over here. And for division, the rules are same. -9 divided by 3 is going to be -3. -9 divided by -3 is going to be +3. So for division and multiplication for negative and positive integers, the rules are same. And for addition subtraction, you put the sign of the bigger number to the answer. And then your factors and multiples. You need to know the difference between a factor and a multiple. If I'm writing 4 times 2 equals to 8, 4 and 2 are factors of 8. Whereas 8 is a multiple of 4 and 2. Multiple is the answer you get after multiplying two numbers, and factors are the numbers that you multiply to get the answer. So you need to know the difference between a factor and a multiple. If you don't know that, you will always end up getting the HCF and LCM question wrong, and as well as this one. So that is another thing you need to know. Then percentages. So in this question, if you look at this, it says a computer costs $560. In a sale, this cost is reduced by 20%. So when it's percentage reduction, that means we are subtracting that percentage from the initial value. Either you can do 560 minus 560 times 20 over 100, or you can just do 560 times 80 over 100. 560 minus 560 times 20 over 100 means that first you're finding 20% of 560, which is this part. That gives you 20% of 560. And when you get that, you subtract that from 560 to get the new value, the discounted price. This one tells us that we're finding 80% of 560. Why? Because 20% has already been reduced. So out of 100, if 20 is taken away, that leaves us with 80. So 80% of 560 gives us the new price. So you can use either ways, but when it talks about reduction, it's like 20% reduction, so it's 80% of the price. And if it's an increase, let's say it was increased by 20%, then it would be 120% of the price. So you need to know about the distinction between reduction and increase in percentages. Then for this, again, difference of perfect squares, I need to know about factorizing a quadratic equation. In the numerator, when you have three terms and the highest power of x is 2, and the highest power of x is 2, it's a quadratic equation. And to factorize a quadratic equation, you can use middle term breakage or the quadratic formula, whichever is easy for you to use. And I've already discussed this detail in the algebraic fraction video, which I'm attaching the link above. I've taken several possible questions in that video and explained this concept again and again. So please, if you need to learn how to factorize a quadratic equation, please use that. Okay, fractions now. So for this one, like I mentioned before, when you have fractions being multiplied, or like a fraction or whole number being multiplied, we can simplify vertically or diagonally, not horizontally. Horizontally, we can only multiply. And it's always advised to simplify because this is paper 2. You're not allowed to use the calculator. So make your calculation easier. Don't make it lengthy by multiplying the numerator with the numerator and denominator to the denominator and denominator to the denominator and then simplify it. That's going to be harder. So if you look over here, m is getting divided by m. So m divided by m is going to be 1. Then 15 and 25. 5 times 3 is 15, so this becomes 3, and 25 is 5 times 5. You need to know your times table by heart. I know you guys are dependent on your calculators, but it's time to like bring back the mental math. Need to your times table till 12. You need to know them. Because if you don't know them, you can't quickly pick on which number comes in which times table. How can we simplify it? It's very important. So memorize your times tables if you've forgotten them. That's essential at this point. Then whenever we have fractions with unlike denominators being added or subtracted, we have to make the denominators equal. You do not have to make the denominators equal when you're multiplying or dividing fractions. It's only important when you're adding or subtracting fractions. This is a mistake that kids very commonly make. They think that they have to make the denominator equal every single time. No, you don't have to. It's only important when you're adding and subtracting fractions. So make the denominators equal only when adding or subtracting fractions with unlike denominators. If you're multiplying or dividing fractions with unlike denominators, you don't need to make them the same. And also when you're making them the same, you multiply the same number to the numerator and the denominator, not just the denominator. Let's say we're doing 1 over 3 plus 2 over 5. So I'm going to multiply both the numerator and denominator by 5 and over here by 3, not just the numerator. And when you're adding the fractions or even subtracting them, you only add or subtract the numerator after this, not the denominator. Denominator remains the same as 15. So this is 5 over 15 plus 6 over 15. So when you add it, it's going to be 5 plus 6 over 15. We combine it as a single fraction and denominator remains the same. Numerator is the only thing that's changing. Denominator is going to be the same in addition and subtraction of fractions. Then for this one, you will use two things from surds that is also present in algebra. So to rationalize a surd, what we do is we times it by the denominator, but with the opposite sign in the middle. The reason why there's an opposite sign in the middle is because we want to make sure that in the denominator, one bracket has positive and the other has negative in the middle. Why? Because then it's going to resemble difference of perfect squares. It's the same as A plus B, A minus B. So when it's the same as that, we can automatically rewrite this as root of 7 square minus 2 square. Root of 7 square, I told you the 2 gets multiplied with the power of 1 over 2 and that becomes 1. So it's 7 minus 4, and that's 3. That's how you solve your denominator in rationalizing surds. Every single time it's going to be like this. Whenever you see the two brackets, one is positive and one is negative in the middle, first thing needs to come to your mind is difference of perfect squares. And you immediately rewrite it as the square of the value of A and B being subtracted, then simplify it, and for the numerator, you're multiplying. You multiply the whole number with the third, whole number with the other whole number, and simplify to get the answer. Easy 2 marks. Okay, so for this one, when they're asking you to simplify two surds, either the surd existing on its own or the surds being added or subtracted. Remember that you cannot add or subtract surds with different numbers inside the root. It has to be the same number for you to add or subtract them. You can multiply them if they're being multiplied, but you cannot add or subtract them. So to simplify the surd, you need to know prime factorization. For prime factorization, you need to know a times table. If you don't know your times table by heart, you won't be able to do this. Now 125 breaks down to 25 times 5. 25 breaks down to 5 times 5. Prime factorization means that we are breaking down the number into a product of its prime factors. So 125 is the same as 5 times 5 times 5. Now if we do the same for 20, 20 is 4 times 5. 4 is 2 times 2. So 20 is 2 times 2 times 5. So first thing for simplifying a surd, you prime factorize the number inside the surd. Break it down into its prime factors. Now 125 is replaced by 5 times 5 times 5. 20 is replaced by 2 times 2 times 5. Now if I combine the 5 and 5, that's 25 times 5. And over here 2 times 2 is 4. If you didn't know that 25 is a square number, 4 is a square number, you won't be able to solve this further on. We have to identify your square cube numbers depending on what the equation is. If we had not identified that, you would just stop over and go back to the initial equation, which is root 125 minus 20. That's not what the question is asking. The question is asking us to simplify it. So square root of 25 is going to be 5. So this 25 comes outside as a 5 and the other 5 remains inside. Similarly, square root of 4 is 2. So the 4 comes outside as 2 and the 5 remains inside. Now you can see that we have fully simplified root 125 as 5 root 5 and root 20 as 2 root 5. Now you can subtract them because the numbers inside the root are exactly the same. So that's 3 root 5. We don't subtract the numbers inside the root, they remain as it is. You subtract the numbers outside. So 5 minus 2 is 3, and that's your answer. So this is how you simplify a surd. Once again, you need to know your square numbers, cube numbers, times table. If you don't know all of that, you will struggle every single time. Now, in the second part, they're talking about the area. So when we're trying to find the area, or another thing, in area, we always multiply the lengths. We don't add them, we multiply them. In perimeter, we add the lengths. To this test, kids still get confused like, are we multiplying or adding? Perimeter is your boundary of the shape. So in talking about the boundary, we are going from one point to the other till we reach the same point that we started with. So we're adding the lengths. Area is a space that a shape occupies. So to find out the space that a shape is occupying, we multiply the length and the width. So over here, K, which is the area, is going to be 3 root 8 times 2 root 2. So previously we talked about subtracting surds with different numbers. Now it's multiplying. So when you're multiplying them, I mentioned earlier as well, you can multiply them easily. There is no restriction on that. The number outside gets multiplied with the number outside, and the number inside gets multiplied with the number inside. So 3 times 2 is 6, 8 times 2 is 16. Now once again, square numbers are coming. If you did not know that 16 is 4 square, you wouldn't be able to simplify it. Square root of 16 becomes 4, so 6 times 4, and that's 24. Square and cube numbers are very important, so please don't miss out on memorizing those. So that was surds. Next we're talking about recurring decimals. So for recurring decimals, once again, I've already made a video on that. I'm attaching a link above for it. It has 3-4 basic steps, very basic steps. In this one, when you see the dot on a number, that means that that number is being repeated. So if I write 0.23 with dots on it, that means it's 0.232323, like 23 is repeating infinitely. So over here, it says 0.114 with the dots on 1 and 4. That means going to be 0.11414. The last 2 digits are being repeated, not the first one. So you have to know how to identify that. If you don't know how to do it, then your question will be incorrect. So the numbers on which the dots are present, that is the number that is being repeated. So over here, work out 0.114 recurring plus 0.2. So in this first, you identify that the recurring number is x. That's the first thing. Next, you need to move the decimal. So why are we moving the decimal? Because we want to create a fraction out of this as identified in the question. So if I times x by 10, that means I'm multiplying 10 with 0.11411414 recurring. So when you're multiplying a decimal by 10, you move the decimal one place to the right side. Whenever you're multiplying a decimal with 10, 100, or 1000, you move the decimal to the right-hand side depending on how many zeros there are in 10, 100, or 1000. If you times it by 100, you would move the decimal 2 places to the right. If you times it by 1000, you would move it 3 places to the right. Similarly, if you were dividing it by 10, 100, 1000, you would move it towards the left side. So if I divide the same number by 10, it would move it 1 place to the left side. If I divide the same number by 100, it would move the decimal 2 places to the left side. So you need to know about this in decimals, that when you're multiplying a decimal by 10, 100, or 1000, the decimal moves towards the right side. In division, it moves to the left side. So now this gives us the answer of 1.141414 being repeated. Next, I'm going to times x by 1000. So that means 1000 times 0.11411414 and so on. So now, as I said earlier, if you times it by 1000, moves the decimal 3 places to the right. So that's going to be 114.141414 and so on. Now, the reason why I chose 10 and 1000 to multiply with x is because I want to make sure that the numbers after the decimal are same in both the calculations. With 10x, I'm getting 1.141414, so 14 after the decimal. 1000 times x is also giving me a pattern of 1414 after decimal. If I had multiplied by 100, it wouldn't give me 1414. It would give me 414414. We don't want that. For us to get rid of the decimal and make it into a fraction, we need to have the same numbers after a decimal. If we don't, then we can't change the decimal into a fraction. So now, next what you'll do is you will subtract 1000x and 100x and 10x. And on the right hand side, we will subtract 114.14 recurring and 1.14 recurring. So 1000x minus 10x is 990x and 114.14 minus 1.14 recurring is 113. Okay, so when you talk about subtracting decimals, you have to make sure that the decimals are aligned. The decimal needs to come underneath the decimal in addition and subtraction. If it doesn't, your answer will be incorrect. So this gets subtracted from this from this. 4 minus decimal comes down as it is. We're not changing the place of the decimal. It's going to come down as it is. 4 minus 1, 3, and then 1, 1 as it is down. So for addition and subtraction of decimals, you will put the decimal underneath the decimal. You will not change its place value. It's going to come right underneath the decimal. So then to find x, we just divide this by 990 and we had a plus 0.2 over here. So if I add it over here, now through this question, you can also learn how to convert a decimal into a fraction. We have 0.2. So to convert this into a fraction, I will move the decimal one place to the right. When I move it one place to the right, I add a 0 with 1 in the denominator. I mentioned previously, every number has a denominator of 1, whether it's written or not written. Whether it's a whole number or a decimal, it has a denominator of 1. So when you move the decimal one place to the right, we add a 0 in the denominator. So that gives us 2 over 10. If you move the decimal 2 places to the right, you add 2 zeros in the denominator. If you move it 3 places to the right, you add 3 zeros in the denominator. So it's about how many places you're moving the decimal. So to convert a decimal into a fraction, you move the decimal towards the right side. So now this is rewritten as 113 over 990 plus 2 over 10. And then you just make the denominators equal like we discussed before and combine the fraction. That's how you do it. And also, if you're trying to convert a decimal or a fraction into a percentage, so for a decimal to percentage, you will always times it by 100. 0.2 times 100. So 1, 2, 2 places to the right. That's 20%. If it's 2 times 100, that's 200. Another thing, when you're multiplying by 100, if it's a whole number, you just add 2 zeros at the end of the number. If you're multiplying a whole number by 10, you just add 1 zero at the end. So that saves your time. You just add the zeros. But if it's a decimal and you're multiplying it by 100, 10,000, or whatever, you just move the decimal that many places to the right side, depending on how many zeros there are in the number. So that's decimal to percentage. And for fraction as well, you times it by 100. So that's 20%. So that's how you convert a decimal, a fraction, or a whole number into percentage. Then you need to know the distinction between parallel and perpendicular lines. Parallel lines have the same gradient. Parallel lines are lines that do not meet. They're always running along each other, like they're never going to intersect. So this is line 1, this is line 2. So M1 is your gradient of line 1 and M2 is your gradient of line 2. So both of them will be the same. But when we talk about perpendicular lines, perpendicular means that both the lines are at right angle to each other. So they're making a 90-degree angle at their intersection. These lines will intersect. Parallel lines do not intersect. So when you talk about perpendicular lines, you need to remember that gradient of line 1 times gradient of line 2 will always equal to -1. So when you get a question for perpendicular lines or parallel lines, you need to know about the gradients. For parallel lines, the gradients are going to be the same. For perpendicular lines, both the gradients multiply and give a -1. So that's important for coordinate geometry. Then we've already discussed the question for this, but oh, one thing over here. You need to know the different types of angle. Any angle that's less than 90 is acute. This is your 90 degrees. So that's a right angle. Then any angle greater than 90 is obtuse. So obtuse angle is greater than 90 but less than 180. Then we have reflex. That's greater than 180 but less than 360. So you need to know your different types of angles. If you don't, you won't be able to understand what angle they're asking for. They've clearly identified a reflex angle. So they want the value that's bigger than 180 for cos x equals to 1 over root 2. First steps are going to be exactly the same as we learned in the initial questions for trigonometry, but you need to select the right angle, which will be based on your knowledge of what each type of angle is. So that's what you need to know for angles. This is the same. Okay, line of symmetry. Line of symmetry is always your x value. So if they've given you the minimum point of a curve, this is your quadratic curve. This is your minimum point. If it's an upside down U, it's your maximum point. So your line of symmetry is always going to be your x value, not the y value, because the x value is dividing the graph into two equal parts, not the y value. So line of symmetry is always x. Not the y value. So in this case, it's x equals to -3. Then when they talk about writing down the equation in completing square form, we always use our coordinates of the turning point, which is your minimum and maximum point. So they told us that the minimum point is -3, -5. It's going to be y equals to x plus 3 whole square minus 5. That's your answer. A value is always the x value of this, and B value is the y value of this. You don't have to do any calculation. If it's a 1 mark question, remember there is not much calculation. You just have to use your knowledge and the question. That's it. 1 marks are like no calculation questions in most cases. So this is what your line of symmetry is. Line of symmetry in quadratic equation is always going to be the x value. Then you need to know about what asymptotes are. So asymptotes. So when I talk about the term asymptotes, asymptotes are basically lines through which your graph do not intersect. So that comes in your tan graph. Your tan graph is like this. There is a dotted line over here like this. And then there's this, and again a dotted line. So these dotted lines are your asymptotes, points at which your graph does not exist. So whenever you hear the term asymptote in a question and they're asking you to identify it or like pinpoint it, it's the point where your graph does not exist or like it doesn't pass through that point. That's an asymptote. Then we've already discussed this, that anything to the power of 0 is 1, and like how you can make your power positive and negative. And then look, same thing over here, like I talked about before. square and cube numbers. They're asking you to rewrite them as 3. If you didn't know that 27 is 3 cube and 81 is 3 to the power 4, you wouldn't be able to solve this question. Times tables are very important. Like if you don't memorize this, trust me, it's going to be difficult. Then question number 9, we've discussed this already, rules of indices. And okay, for vectors. So whenever they're saying like this vector equals to this, find like 2 times that vector or like 5 times that vector in this case, remember that you're multiplying 5 with both the top and the bottom value. It's not going to be just with the top value, it's with the entire vector. So 3 gets multiplied with 5 as well, and -4 also gets multiplied by 5. Don't miss out on that. And for the magnitude, you know the formula, it's going to be square root of 3 squared plus -4 squared. Again, for this, you need to know what 3 squared is. That's 9. -4 squared is 16. So if you don't know these, you're going to make an error. Then the next thing you need to know about is what is a prime number, what is an odd number, even number, integers, natural numbers, negative integers, these things. So let's talk about that. Now, prime numbers are numbers that are only divisible by 1 and itself. So prime numbers begin from 2. 1 is not a prime number. 2 is a prime number. 2, 3, 5, 7, 11, 13, 17, and so on. These are your prime numbers. You have to know what the smallest prime number is, which is 2, not 1. So if you just remember that, 3 onwards, it's very easy to figure out. The next thing is your natural number. Natural numbers are numbers that begin from 1. So 1, 2, 3, 4, 5, 6, 7, all of the numbers till infinity. Then you know what odd and even numbers are. Even numbers are numbers that end with an even number. Odd numbers are numbers that are like ending with an odd number. And integer. Integer is like a positive and a negative whole number. So a negative infinity to positive infinity. But we have whole numbers over there, not decimals. So integers are not decimals. Then irrational numbers are numbers which cannot be expressed as a fraction. Cannot be expressed as fractions. So that's how you differentiate between a rational and an irrational number. For a rational number, you can rewrite it as a fraction, but an irrational number cannot be rewritten as a fraction. So these are the main types of numbers you need to know about. Then distinction between simple interest and compound interest. Simple interest is basically giving you the interest that you've earned in a specific time period, whereas the compound interest is giving you the final value after the time period has been completed. So this is final value, interest earned. You need to know about the distinction between the two. So simple interest formula is principal amount, which is the initial amount, times the rate of interest over 100 times the time period. Compound interest formula is the initial amount times 1 plus rate of interest over 100 to the power of t. So this is how you differentiate between simple interest and compound interest. Another thing, your exponential increase has the same formula as the compound interest formula, which is initial amount times 1 plus rate over 100 to the power of t. Whereas your exponential decrease formula, that's p times 1 minus r over 100 to the power of t. So the exponential increase-decrease formula is the same as the compound interest, but the sign changes in the middle depending on whether it's increase or decrease. Then this is the fraction thing that I was talking about. Okay, so now in this case, we have subtraction and multiplication, which means we'll follow BIDMAS over here. BIDMAS means that we do brackets first. If we have brackets in the equation, then we do indices, then we divide, multiply, add, and then subtract. This is the order in which we solve an equation. So whichever comes first, we do that first. So in this one, we only have subtraction and multiplication. Looking at our BIDMAS grid, we can see that multiplication comes before subtraction. So that means we will solve this first. So 5 over 6 minus 2 over 3 times 3 over 8. Like I said before, simplify your fraction when you're multiplying them or dividing them. So we know simplification can be done vertically or diagonally. 3 divided by 3 is 1. 2 divided by 8 is 1 over 4. So we have 5 over 6 minus 1 over 4. Now, when we're subtracting fractions, we have to make the denominators equal. So we can make the denominator 12 because 12 comes in the 6 times table and the 4 times table. So multiply the first fraction by 2 and the second fraction by 3. That's 10 over 12 minus 3 over 12. So then just subtract the numerators and that's 7 over 12. So remember, if like more than one operation is happening in the equation and it's just like numerical or even like with variables, follow the BIDMAS grid. Whatever comes first, you do that first. And in this case, multiplication first and then subtraction. Then all of this is what we've done already. We've done this. Okay, this is different. So identifying the line of symmetry or the rotational symmetry of order. For the line of symmetry, you need to see how the shape can be equally divided. So if I just draw a line like this, we can clearly see that if we shade this square, we have one line of symmetry. That's it. There's not going to be two line of symmetries. The shapes need to be identical on both sides for them to be symmetrical. The shapes need to be identical on both sides for it to be symmetrical. So this is the only way it's identical. Then shade one more small square so that the diagram has rotational symmetry of order 2. So you need to understand what rotational symmetry is. Rotational symmetry is that you are getting your shape in its original form, like the number of times you're getting your shape in its original form while you're rotating it from 0 to 360. So like for example, we have this rectangle over here, okay? This is at 0 degrees. If I rotate it 90 degrees, let me highlight this point over here. So we're focusing on this point that we're rotating. So it's going to be like this. This point is going to come over here. This is 90 degrees. And if I again rotate it, this point is going to be over here. So this is 180 degrees now. We can see that it has reached its original form once over here. Then again rotate it. Now this point comes over here. So this is 270 degrees. And now lastly 360. So this is the point back over here. So 2 times the shape gained its original form while we rotated it from 0 to 360 degrees, which means the rectangle has a rotational symmetry of order 2. This is how you identify the rotational symmetry of order for any shape. I've also made a video about like the rotational symmetry of order and like line of symmetry for different shapes. It's a short, so you can access it at the link above. You can even memorize those for your better understanding and to make sure that you don't get confused. So now over here, I think shade one more small square so that the diagram has a rotational symmetry of order 2. So if we shade this square, let's say, okay, so this is at 0 degrees. At 90 degrees, it's going to be, the shaded squares are going to come over here and these two are going to come over here. This is 90. Then again, Now this shaded square over here, this is going to be over here. That's 180. So 1 is already over here. We have reached the original form. Then for 270, it's going to be over here and it's going to be over here. And then for 360, it's again over here. So we can see that we reached the original form 2 times when you rotated it complete 360 degrees. So that means we shade this square over here. So that was your concept for rotational symmetry of order and line of symmetry. Then we already talked about this, that when you're moving a term from one side to the other side, it does the opposite on the other side. So when I take 7 over here, it's going to be 8x equals to 39 minus 7. It does the opposite thing. And then when I take 8 over here, it's going to be x equals to 39 minus 7 over 8. So again, it was multiplying on the left-hand side. On the right-hand side, it divides. Then we talk about expanding brackets. The term outside the bracket gets multiplied with the terms inside the bracket. So 2 times 5y is going to be 10y. And then 2 times negative 1 is going to be negative 2. We cannot solve 5y negative 1 because 1 is a variable and 1 is a constant. We can only combine like terms, and I've already told you initially that like terms are like same variables with the same variable, numbers with the numbers. So that's 10y equals to then 24 plus 2 because we moved it to the other side. And then we take 10 to the other side, and now it's going to be division. So that's how we do this. Then we've already discussed what factors and multiples are, and if you're someone who needs to understand how to find the highest common factor or lowest common multiple, you can check out the link above because in that video I've discussed these questions in thorough detail. Then the next question, they have a question about standard form. So I'm specifically going to focus on part B. So for standard form, you need to know that in standard form, your decimal needs to come after the first non-zero digit. First non-zero digit over here is 7. So your decimal needs to come after 7, not before 7. Not before, not after 0 between the 7 and 8, not after 8. It needs to be after 7. So we know that when you move the decimal 1, 2, 3 places to the right, it comes between 7 and 0. So it's going to be 7.08. Now we move the decimal 3 places to the right side. So that means your power is going to be negative 3. If you had moved the decimal 3 places to the left side, then the power would be positive 3. So you need to know that the sign of the power will be based on the direction in which the decimal is moving. If the decimal moves towards the right side, then the power is negative. If the decimal moves towards the left side, the power will be positive. But this rule applies when you're converting the answer from ordinary number to standard form. 0.00708 is your ordinary number form. And when you write it as something times 10 to the power of something, that is your standard form. So this is your standard form. And like I said, in standard form, the decimal needs to come after the first non-zero digit. Then work out 3.8 times 10 to the power of 22 plus 3.8 times 10 to the power of 23, giving you answer in standard form. So you have to keep in mind that we cannot use a calculator in this paper. So how will you solve this question? You have to identify what's common between both of these brackets. So we can clearly see that we have a 3.8 common, and then we have a 10 common, but the powers are different. So whenever we're trying to find the highest common factor between two things, we pick the smallest common power, which is 22 over here, because 10 to the power of 23 can be split into 10 to the power of 22 times 10 to the power of 1. Over here, we're applying the rules of indices. When we are multiplying similar bases, we add the powers. So if we do the reverse thing, I'm rewriting it as a product of similar bases. So the powers are going to be 22 and 1. And why are we specifically choosing 22? Because the other 10 also has a power of 22. If it, let's say, had the power of 10, then you would split it as 10 and 30. So it depends on what the other base has the power for. So it depends on the power of the other base. There is no other restriction. If the other base has a power of, let's say, 20, so then you would split this as 20 and 3. So 3.8 times 10 to the power of 22 is taken common over here. So that leaves 1 plus 10 in the bracket. Now 1 plus 10 is 11. So we are multiplying 3.8 times 10 to the power of 22 with 11. Now comes the multiplication of a decimal with a whole number. So 3.8 times 11. When you're multiplying a decimal with a whole number, the steps are the same as you're multiplying a whole number with a whole number. And over here, we're going to use column multiplication. So this is something that you've learned in the previous years several times, but if you've forgotten it, you're lucky to revise it again. So when you're multiplying these numbers, first you multiply 1 with 8 and then 1 with 3. So that's 8 and 3. Then you put a placeholder over here. You can put a 0 or an X, whatever you want to use. Then I'm going to multiply this one with 8 and this one with 3. So that's 8 and 3 again. Add these up. 8 plus the placeholder is 8 itself because the placeholder is basically 0. 3 plus 8 is 11 and 3 plus 1 is 4. Now the decimal. If there's more than one decimal, like for example, both the numbers had a decimal, then you would add the decimal places of both the numbers and then the answer would have the result of that. So for example, if it was 1.1 times 3.8, that gives us 2 decimal places in total. 1 decimal place for this and the other for this. So then the answer would be 4.18. But in this case, since we only have 1 decimal place, so it's going to be 41.8. So it all depends on the decimal places. You count the decimal place for both the numbers, add it up, and that gives you the decimal places for the answer. So now it's 41.8 times 10 to the power of 22. So like we mentioned previously, in standard form, the decimal needs to come after the first non-zero digit. Over here, it's after the second non-zero digit, which means we move the decimal 1 place to the left. So when I move it 1 place to the left, it's going to be 4.18 times 10 to the power of 23. Now we're adding 1 to the power. When you went towards the right side, the power was negative. When you move the decimal to the left side, the power is going to be positive, and we're going to add 1 to it, depending on how many places the decimal is moving. In this case, it moved 1 place, so you add 1 to the power of 10. If it moved 3 places, you would add 3 to the power of 10. So in this question, you learned standard form, how to solve those questions without a calculator, how to take the highest common factor common, how to multiply decimals, and how to give an answer when it's decimal times decimals or decimal times whole numbers. So let's move on to the next thing. We've already talked about multiplying fractions, adding fractions, so I'm going to skip this. This is the question I want to do now. So over here, we're dividing a mixed number by a proper fraction. What is a proper fraction? A proper fraction is a fraction when the numerator is small and denominator is big. So for example, 3/10, this is a proper fraction. Improper fraction is when the numerator is big and denominator is small. So now it's 10/3. That's an improper fraction. And mixed number is when we have a whole number and a proper fraction together. So 3 whole number, 1/2. That's a mixed number. So these are the 3 different types of fractions you need to know about. So over here, the question is saying 1 whole number 1/3 is divided by 8/15. You have to give your answer as a mixed number in its simplest form. So first, we convert the mixed number into an improper fraction. That is going to be your first step, whether you're adding mixed numbers, subtracting mixed numbers, dividing, or multiplying. So to convert the mixed number into an improper fraction, you multiply the denominator with the whole number and then add the result to the numerator.
So it's going to be 3 times 1, which is 3. And then 3 plus the 1 in the numerator, that's 4. So your fraction is going to be 4 over 3 divided by 8 over 15. Once we've converted this into an improper fraction, now comes the division part. When you're dividing fraction, whether it's fraction by fraction, whole number by fraction, or fraction by whole number, you always keep the first fraction as it is, change the division into times, and flip the second fraction. KCF. Keep the first fraction, change division to times, and then flip the second fraction. So 4 over 3 times 15 over 8. Now, I mentioned earlier when you're multiplying fractions, it's best to simplify it. Simplification is done vertically or diagonally. So we know 4 and 8 come in the same times table, which is the 4 times table. 4 ones are 4, 4 twos are 8. Same for 15 and 3, 3 ones are 3, 3 fives are 15. So that leaves us with 5 over 2. Now 5 over 2 is an improper fraction because the numerator is bigger than the denominator. They want the answer as a mixed number. To convert an improper fraction into a mixed number, we divide the numerator by the denominator. 2 twos are 4. 5 minus 4 is 1. So 2 whole number 1 over 2 is your answer as a mixed number in its simplest form. Your remainder becomes the numerator, denominator remains the same, quotient becomes your whole number. So that's how you solve this. Then we've already talked about product of prime factors. You prime factorize 42, and then you write down the answer as a product of its prime factors. So 42 is 7 times 6. 7 is a prime number, so we cannot break this down. 6 is 3 times 2. 3 and 2 are prime numbers, so we cannot break these down. So 42 is 7 times 3 times 2. You need to know that the smallest prime number is 2, not 1. If you make the mistake of breaking 2 or 3 down, you're not going to get full marks. So you need to make sure that 2 is included in the prime numbers. Then we talk about shapes. It says a quadrilateral has one line of symmetry. The diagonals of the quadrilateral cross at right angles. Write down the mathematical name of this quadrilateral. So for you to be able to confidently answer this question, you need to know what are the different types of quadrilaterals. So let's go through the quadrilaterals now. We have a square. You need to know what are the properties of a square. A square has all equal lengths. All angles are right angles, so they're all equal. Then it has 4 lines of symmetries. 1, 2, 3, 4. Then it has rotational symmetry of order 4. And the diagonals meet at right angles. So this is for a square. For a rectangle, 2 lines of symmetries, all angles are right angles, opposite lengths are equal, and the diagonals meet at right angles as well. So it's similar to a square, but the lengths are not equal, and it has less line of symmetries. And rotational order of symmetry is going to be 2 for this. So order 2. Now, talking about a parallelogram, which is the third quadrilateral. In a parallelogram, opposite sides are equal. So that's the same as your rectangle. Opposite angles are equal. Parallelogram. Your diagonals don't meet at right angles. So diagonals don't meet at right angle. This is a right angle symbol. But opposite lengths are equal, opposite angles are equal. So for this, your rotational symmetry is going to be order 2 again. Now, next shape I'm going to talk about is the rhombus. So in a rhombus, it's similar to a parallelogram in like visual, but it has all equal lengths. So a rhombus has all equal lengths, and for a rhombus, your diagonals are going to meet at right angles, just like the rectangle and the square. So diagonals meet at right angles. That's for a rhombus. So all lengths are equal. Opposite sides are equal and parallel to each other. So these are parallel to each other, like in a parallelogram, but it has equal lengths. In a parallelogram, you don't have equal lengths, but in rhombus, you do have equal lengths. And your opposite angles are equal to each other. So this angle is equal to this, and this angle is equal to this. So this is like a mixture of a square and a parallelogram, if you come to think about it. And the order of rotational symmetry is going to be 2 for this as well. Fifth quadrilateral I want to talk about is your kite. Now, in a kite, the top two sides are equal and the bottom two sides are equal to each other. The diagonals are meeting at right angle for this as well. And these two angles are equal. The kite has one line of symmetry and its rotational order symmetry is also 1. So based on what we know over here, a quadrilateral has one line of symmetry. For this case, the diagonals are meeting at right angles. So write down the mathematical name of this quadrilateral. So also for rhombus, I forgot to mention it has two line of symmetries. For a parallelogram, there are no line of symmetries. No line of symmetry. I know this is a bit untidy, but I would suggest write it down like neatly in your notes so that you know what are the properties for each shapes. And if you learn these properties, then these type of 1 mark or 2 mark questions are going to be easily scoring for you. So based on our question, it's a quadrilateral. So these are all of your quadrilaterals. Then its diagonals are crossing at right angles. So we know for that it's a square, rectangle, and rhombus and a kite. But it has one line of symmetry. So one line of symmetry is only for the kite. So that's going to be a kite. There's another quadrilateral that you should know, which is a trapezium. So for a trapezium, the only time it can have one line of symmetry is if it's an isosceles trapezium. An isosceles trapezium has these two lengths equal and these two angles equal to each other as well. So if you have an isosceles trapezium, then it has one line of symmetry and the rotational symmetry order is going to be 1 as well. So order 1 and line of symmetry is also 1. So these are all of your quadrilaterals that you need to know about. For your triangles, you have an equilateral triangle. Let me just write that down over here. Equilateral, where all sides are equal and all angles are equal. That's going to be 60 for each angle. That's equilateral. For an equilateral, we have rotational symmetry of order 3 and we have 3 line of symmetries. Then you have your isosceles triangle where two lengths are equal and two opposite angles are also equal. For an isosceles, you have one line of symmetry. After that, we need to know about the right angle triangle where we have just a 90-degree angle over here. If you have the 90 degree, it's a right angle triangle. Scalene triangle is when you have no equal sides. So this is different, this is different, this is different. So these are your 4 types of triangles that you need to be aware of. Apart from that, you have your polygons. And if you're someone who doesn't know like what your like common polygons are, I'm attaching a link above for a short. In this short, I've written down names of all of the polygons along with visuals for its shapes, line of symmetry, and rotational order. So do check that out. So in the next question, we're talking about ordering decimals. But if you notice, these decimals have different metric units. So this is very important. What most kids do is that they just rearrange the decimals based on the numerical value and like the unit attached to it. But they don't realize that for you to fully compare these values to each other, firstly, they need to be in the same format. Either all of them need to be in decimals, fractions, or percentages. In this case, we have the same format for the numerical value, which is a decimal. What's missing is that they don't have the same metric unit. One measurement is in meters, other in centimeters, then millimeters or kilometers. We have to make sure that they're in the same metric unit so that you can properly compare them and accurately give your answer. So you can either convert them all into meters, centimeters, millimeters, or kilometers. My suggestion is that convert them into the smallest unit because this way your calculation becomes easy. How does it become easy? Because when you're going from a bigger to a smaller unit, you are multiplying like the value by what it's equal to. Like, for example, if I say that I want to convert 20 centimeters into millimeters, I know 1 centimeter is 10 millimeters. So it's 20 times 10. So multiplication is easier compared to division for most kids. Like it's something psychological, I think. I don't know, but it's easier. So convert all of them into the smallest unit and then compare them. And for you to convert them correctly, you need to know what each metric unit equals to. So let's start with the conversions first. 1 centimeter is 10 millimeters. You need to revise these as well. Memorize these because these are not going to be given to you in the paper. 1 meter is 100 centimeters. 1 kilometer is 1,000 meters. And if you want to write 1 kilometer as centimeters, that's going to be 100 times 1,000. So that's 100,000 centimeters. And if you want to write 1 meter into millimeters, let's say that's going to be 100 times 10. That's 1,000 millimeters. So this is how you can convert them into different measurements, but make sure that you convert the bigger ones into smaller ones to compare easily. So we are going to convert these into millimeters. So 1 meter is 1,000 millimeters. So we do 0.03 times 1,000. And like I mentioned before, if you're multiplying by 10, 100, or 1,000, you move the decimal towards the right side based on how many zeros in the number are. So 1,000 has 3 zeros, 1, 2, 3. So that's 30 millimeter. 2.9 is going to be multiplied by 10 because 1 centimeter is equal to 10 millimeters. So move the decimal one place to the right. That's 29 millimeters. Easy as that. 32 millimeters is already given into millimeters, so we don't need to change that. To convert the kilometers into millimeters, we know that 1 kilometer is equal to 100,000 centimeters. So for millimeters, we times this by 10, so that's going to be 1 million. So that means we're going to multiply 0.002 by a million. So that means we move the decimal 1, 2, 3, 4, 5, 6 places to the right, which gives us 20 millimeters. So now that we have all of the values in millimeters, now we can correctly compare which one is the smallest. So you can clearly see that the smallest value is 20 millimeters, which means 0.00002 kilometers is going to be written first. You will always write your original value in the answer, not the converted one. Then next we have is 29 millimeters, which is 2.9 centimeters. So 2.9 centimeters goes over here. Then after that, we have 30 millimeters. So that's 0.03 meters. And lastly, 32 millimeters. So remember to keep in consideration the numerical value and the metric units. If you just pick one thing and rearrange your answer on the basis of that, it will not be correct. So for these type of questions, remember to memorize your metric unit conversions. You need to know for liters as well. 1 liter is 1,000 milliliters. Then 1 centimeter cube is equal to 1 milliliters, which means 1 liter is also the same as 1000 centimeter cube. 1 kg is 1000 grams. 1 hour is 60 minutes. And 1 minute is 60 seconds, which means 1 hour is going to be 3600 seconds. All of these things need to be on your fingertips. Next, what we're talking about is significant figures. So you will be given a question like this, and they will say by writing each number correct to one significant figure, work out an estimate for D. This is a very common question. So what we do over here is that we'll rewrite all of these numbers correct to one significant figure. So for you to do that, you need to understand how significant figures work. So let's say we have a number 20. 20 is one significant figure. How do we know it's one significant figure? Because in significant figures, leading zeros are not considered to be significant. Leading zeros are zeros that come at the end of a number. So like if our number is 10,000, so only number one, the first digit is significant. All of the zeros after it are insignificant. So any number with zeros at the end, those zeros are not considered to be significant. If we had the number 201, now this is three significant figure. Zeros in the middle of two non-zero digits, or like any non-zero digits. If the zeros are in the middle of non-zero digits, it's considered to be significant. Zeros at the end are not significant. Then if it was 0.002, this is also one significant figure. In decimals, zeros written before a non-zero digit are insignificant. So if the zero is in the middle, it is significant. If it's at the end, it's insignificant. If it's a decimal and the zeros are in the beginning, it's again insignificant. So that's how you count your significant figures in any given number. So talking about that, we want to convert 1.95 correct to one significant figure. So we know 1.95 is between 1 and 2. 1.95 is closer to 2, so we can rewrite that as 2, because 2 is one significant figure. Similarly, 9.92 is between 9 and 10. 9.92 is closer to 10, and 10 is one significant figure because the 0 after the 1 is not considered to be significant. Then for 8.07 again, it's between 8 and 9, but it's closer to 8. So we can rewrite that as 8. These are your numbers rewritten correct to one significant figure. Now what you will do is you will replace them in the equation. So 1.95 is 2, this is 10 squared, and this is 8. So 2 ones are 2, and this is 4. 10 squared is 100, so 100 over 4 is being square rooted. 100 divided by 4 is 25. Square root of 25 is 5. Or you can rewrite that as square root of 100 is 10. Square root of 4 is 2. 10 divided by 2, again 5. Both ways are correct. But for you to be able to solve this correctly, you need to know how significant figures work. Leading zeros are insignificant. Zeros at the beginning of a decimal are insignificant. But if it's a zero between non-zero digits, it is significant. These are the rules for significant figures. So this is another thing that you need to be aware of. Then we've already talked about this. Okay, let's talk about time. So it says a night bus runs from 21:50 to 5:18 the next day. Work out the numbers of hours and minutes that the night bus runs. So we're starting at night, which is at 21:50. 21:50 is your 9:50 at night. So from 9:50, we go to 10 o'clock first. So we've covered 10 minutes over here. Then from 10, we go to 11, and then we go to 12. So the new day has started now. So then it's 5 hours from 12 to 5 because we are stopping at 5:18 the next day. and then it's 18 minutes more. So we have 1 hour over here, 1 hour over here, 5 hours over here, and then 18 minutes. So that's 1, 2, 3, 4, 5, 7 hours and 28 minutes. This is how I like to calculate time, like the final time. If you prefer to do it differently, that's also fine as long as you're getting the correct answer. Some people subtract the values, some people add them, depending on what the question is. If they've given you the initial time and the time duration during the journey, then you can find the final value by adding them up. If they've given you the final time and the initial time, then you can subtract them to find the time taken. So whatever works for you, just do that. Then the next question is about simplifying. So this is what I was talking about initially, collecting like terms. 4m and negative m are like terms. 7k and 3k are like terms. So 4m minus m and 7k plus 3k. Solve the m's with the m's and the k's with the k's. So 3m plus 10k. That's it. You leave your answer at this point. You cannot further add these up because m and k are different variables. Like I've said before, we cannot add or subtract different variables. You can multiply them, yes. You cannot divide them because, again, they're different variables. You can only multiply them. No addition, no subtraction, no division. They remain as it is in those three cases. Then for question number 2, this is like before they made it like a non-calculator paper, but like you can still get a similar question. They can give you this like for the significant figure question that we were doing previously, or they can like, give you numbers that can be solved easily. Like they can give you a square number instead of like a decimal number, and then another number that you can cube and like add or subtract. So for this, you need to once again know your square numbers, cube numbers, square roots, cube roots. They'll give you a number that's easy to solve. They won't give you a decimal like this. Then for question 11, we already talked about how to convert a mixed number to an improper fraction, then how to like add or subtract. So I'm not going to solve this, but I would want you to practice this on your own as well, so that you know if you're making a mistake or not. Question 14 is what I would like to do. So a train 1750 meters long is traveling at 55 kilometers per hour. Calculate how long it will take for the whole journey to completely cross a bridge that is 480 meters long, giving your answer in seconds correct to the nearest second. Then for the next type of question, you need to know like how to find average speed. Average speed is distance over time. So you need to know about these formulas like density is mass over volume, pressure is force over area. So these compound measure equations, you need to know about those as well. Then this one, the speed time graph. So you need to know about the properties of a speed time graph and a distance time graph. In a distance time graph, your slope is your speed. So let's write that over here. Distance time graph. Slope equals to your speed or velocity, whatever the question is talking about. If it's talking about displacement, it would be velocity. If it's talking about distance, it's going to be speed. Then in a distance time graph, this is your time, this is your distance. If it's going like this, your distance is increasing, so your speed is also increasing. If it's going like this, like the distance is constant, that means it's at rest. Because obviously, if no distance is being covered, that means the object is not moving, which means it's at rest. That's a horizontal straight line for a distance time graph. It's at rest. Whereas in a speed time graph, a straight horizontal line is constant speed. When the speed is 0, that means rest. For a speed time graph, your slope is acceleration. So when the speed is increasing, it's acceleration. When it's decreasing, it's deceleration. So positive slope, acceleration, negative slope, deceleration. Then for speed time graph, your area under the graph is your distance. So this entire area under the graph is your distance. So distance is area under the graph. These are the main properties for a distance time graph and a speed time graph. So for the area under the graph, like they would commonly ask you find the distance, it will give you a speed time graph, or find the acceleration or deceleration. So for the distance, you would just find the area under the graph. It's mostly a trapezium. So for this, you need to know the formula for the area of a trapezium, which is half times height times sum of parallel sides. This is your formula for the area of a trapezium. So these are your parallel sides. So this is going to be 20 minus 140, which is 120. And this total is going to be 190. So you add it up and then you times it by the height, which is 15, and then times it by 1/2. So for distance, for a speed time graph, always find the area under the graph. And for the slope, we know the formula, which is y2 minus y1 over x2 minus x1. It's as simple as that. These are the things you need to know about the speed time graph and distance time graph. Then question 21, I'm going to skip because I already talked about that in the indices video and initially as well. If you want to go through it in detail, you can check that video separately as well. For inverse direct proportion, you need to know like the equation for inverse proportion, direct proportion. If it's inverse proportion, like over here, it's y is inversely proportional to the square of x plus 3. So inversely proportional means that's going to be 1 over x plus 3 square. So when you remove the proportionality sign, it becomes y equals to k over x plus 3 square. So in inverse proportion, you divide k, the constant of proportionality, by the other thing. So this is inverse. If we talk about direct, like using the same example, it's going to be y is proportional to x plus 3 whole square. So when you remove the constant of proportionality, it's going to be k times x plus 3 square. So for inverse, it's k divided by the other thing. Indirect, it's k times the other thing. That's how you distinguish between inverse and direct proportion. Then we have your upper bound and lower bound. For upper bound and lower bound, over here it says that a car travels 14 kilometers correct to the nearest kilometer. This takes 12 minutes correct to the nearest minute. Calculate the lower bound of the speed of the car. So there are different rules for upper bounds and lower bounds. First, you need to understand how to find the upper bound and lower bound for a value. So we know speed is distance over time. If I'm talking about the lower bound of speed over here, so for that we divide the lower bound of the distance by the upper bound of time. In division, we don't do lower bound divide by lower bound to find the lower bound of something. We have to find the smallest possible value. Smallest possible value can be found if we divide the smallest value by the biggest value. So since it's distance divided by time, so lower bound of distance divided by the upper bound of time. That would give you the least value. If we were dividing lower bound of distance by lower bound of time, that wouldn't give us the least value. Similarly, if we're talking about upper bound, so if we're talking about the upper bound of speed, then it would be upper bound divided by lower bound. Then you would get the biggest possible value for speed. So in division, it's not that we're going to use the upper bound and lower bound both, like, together, upper bound divided by upper bound or lower bound divided by lower bound. No. For lower bound, it's lower bound divided by upper bound. For upper bound, it's upper bound divided by lower bound. Similarly, if it's subtraction, let's say it's upper bound of something in subtraction, then you would do upper bound of the quantity minus the lower bound of the other quantity. And if it's lower bound in subtraction, then it's lower bound minus upper bound. So the rule for subtraction and division is kind of similar, whereas for addition, if we're talking about the upper bound of something in addition, it's upper bound plus upper bound. And for lower bound, it's going to be lower bound plus lower bound. Similarly, for times, it's lower bound times lower bound and upper bound times upper bound. So upper bound times upper bound. And for lower bound, it's going to be lower bound times lower bound. Addition and multiplication have a very simple rule, but for division subtraction, it's like a mixture of both. If you're someone who struggles with understanding like upper bounds and lower bounds, I would suggest you check out the link above because in this video I've used several different questions and explained upper bound and lower bound in quite detail. So going back to this, we are trying to find the lower bound of speed. So we need the lower bound of distance and the upper bound of time. So distance is 14 kilometers, correct to the nearest kilometer. So we're trying to find the bounds for something, whether it's upper or lower. Whatever the given value is correct to, you divide that by 2 first. So where it's correct to the nearest kilometer. So for 14, the nearest kilometer is 1 kilometer. So it's going to be 1 divided by 2, which is 0.5 kilometers. So upper bound would be 14 plus 0.5 and lower bound would be 14 minus 0.5. I know I just need the lower bound for this, but I'm teaching you how to find the upper bound as well in case you didn't know. So that's going to be 13.5 kilometers for the lower bound and 14.5 kilometers for the upper bound. Then this was for distance. Now for time, it's 12 minutes correct to the nearest minute. Again, nearest minute, so it's 1. So 1 over 2 is 0.5 minutes. So that's going to be upper bound is 12 plus 0.5, which is 12.5 minutes. So now for the speed, you do 13.5 divided by 12.5. Move the decimal one place to the right. So that makes it whole numbers. So 135 over 125. Also another thing, if you're moving the decimal one place to the right in the numerator, you do the same in the denominator. So how many places you move it in the numerator, you do the same in the denominator. It's going to be the same in both. So 135 divided by 125. 135 is in the 5 times table, and that's going to be 27, and 125 is going to be 25. So since I think this is from like before we had the non-calculator paper, so that's why the values are a bit odd and you cannot like solve it easily. Let me see if we can divide it. 7 divided by 25, that's 1, 25, 2, 0. No, it's going to keep on, it's going to be lengthy. So I'm going to leave it as it is over here, but in your exam, they would give you a number that can be simplified easily. So that's how you find the upper bound and lower bound in division. I gave you examples for subtraction, addition, and times. The next question, I already told you how to divide a fraction by a number. We keep the first fraction as it is, change the division into times, and flip the second number. Whether it's a fraction or a whole number, you will flip it. So 8 becomes 1 over 8, and then you simplify it. So again, same thing. I'm going to skip this because I've already told you that we have to collect the like terms on each side. So negative t goes over here, it becomes positive t. 8 goes over here, it becomes negative 8. Collect the like terms on each side, simplify it, and then make t the subject and find the value. Same thing. Over here, this is what I would like to talk about. So when you have a fractional like expression on one side or a whole number on the other side, or even a fraction on the other side as well, first step is to get rid of the fraction. And we get rid of the fraction by cross multiplying. Cross multiplication is you're multiplying diagonally now. So 25 minus 2u equals to 2 times 3. When I cross multiply, the 3 goes away from the left-hand side and gets multiplied to the right-hand side. So then it's 25 minus 2u equals to 6. Then the solving part is similar to what you've done previously. You take 25 to the other side. 6 minus 25, that is negative 19. U equals to negative 19 divided by negative 2. When you're dividing two negative integers, it gives a positive answer. So the negative sign gets cancelled out and u is equal to 9.5 because 19 divided by 2 is 9.5. So that's how we solve this. After that, question 8, okay, this you need to know what to do over here. So we talked about rewriting a decimal as a fraction. So to write 0.3 as a fraction, remove the decimal one place to the right. And we know every decimal and whole number have a denominator of 1. So we move the decimal over here towards the right as well. If the decimal is not written, like 6 is the same as 6.0. So we assume that there's a decimal after 1 as well. So we move that to the right-hand side as well. And now we have 3 out of 10. So this is 0.3 whole square. So 3 out of 10 whole square means that it's 3 out of 10 times 3 out of 10. 3 times 3 is 9, 10 times 10 is 100. So it says give your answer in standard form. So now we rewrite this as a decimal again, but now we move the decimal 2 places to the left. So that's 0.09. And in standard form, again, we know that the decimal needs to come after the first non-zero digit. So 1, 2. So that's 9.0 times 10 to the power of negative 2. We move the decimal 2 places to the right-hand side, so the power of 10 is going to be negative. If you think you can solve this differently, which is going to be shorter, that's also fine. You can also do 0.3 times 0.3, column multiplication. 3 times 3 is 9. 3 times 0 is 0. Place value. Put a placeholder. 0 times 3 is 0. 0 times 0 is 0. Add it up. 0, 0, 9. One decimal place over here. Other decimal place over here. So total 2 decimal places, which means the decimal comes over here. It does not come as it is down. It is the sum of the decimal places in the numbers that you multiplied. So both are 1 decimal place, which gives us 2 decimal places. So 0.09. You rewrite this in standard form, which is 9.0 times 10 to the power of negative 2. So you can use either of these ways, or if you know some other method, you can use that as long as you don't need the calculator. Then for the next one, I talked about cube numbers and prime numbers initially. Prime numbers are numbers that are only divisible by 1 and itself. Cube numbers are numbers that we get when you've multiplied the same number to itself 3 times. So 27 over here is 3 times 3 times 3. Like I've mentioned previously, memorize your basic cube numbers and square numbers. Then for prime number, it is only divisible by 1 and itself, that's 29. 29 does not come in any of the times table. It's only the 1 times table and the 29 times table. Then over here, for inequalities, your solving part is the same as solving an equation. But what changes is that if your variable is negative when you're solving it, then one step changes. So let's say over here, like we had negative 2x is greater than equal to 4 over here. So they're asking us to find the value of x. So we're going to divide both sides by negative 2. When you divide both sides by negative 2 in inequalities, what happens is that your inequality flips. So flipping the inequality means that it's going to be the opposite. So it's going to be x less than equal to negative 2 now, not greater than equal to. This is the only different thing when it comes to solving inequalities. Otherwise, if we're not dividing by negative numbers on both sides, it's the same as solving a linear equation. So if we're dividing by negative numbers on both sides, then the inequality will flip. So this is another thing you need to know about paper 2 questions. Then what do we have next?
talked about negative integers. We've talked about prime numbers. Question 6. It says, at the end of the day, a shopkeeper has 12 tins of cat food left. This is 3 over 13 of the number. This is 3 over 13 of the number he had at the beginning of the day. Calculate the number of tins he had at the beginning of the day. If he's left with 12 tins at the end of the day, and that represents 3 over 13 of the number he had at the beginning of the day, which means 3 over 13 times x, which is what he had at the beginning of the day, is equal to 12. For these type of questions, you need to learn how to translate your statement into an equation. That is the key takeaway from this. If you can't translate your statement into an equation, then you can't solve this simple algebraic question mixed with fractions. At the end of the day, he has 12 tens. 3 over 13 of the number he had is at the beginning of the day. This is 3 over 13 of the number he had at the beginning of the day, which means 3 over 13 times the initial number of tens equals to 12. So now when I take 13 to the other side, we are cross multiplying. So that's 12 times 13. And when I take 3 to the other side, it's going to be 12 times 13 divided by 3. When you take one term to the other side, if it's doing something on the left-hand side, it does the opposite on the right-hand side. And we've already talked about this in the previous questions. If it's dividing, it multiplies. If it's multiplying, it divides. If it's adding, it's subtracting. If it's subtracting, it's going to add. So 12 divided by 3, we can solve that. That's 4. And then it's 13 times 4. If you don't know how to do mental math, just do column multiplication. It's fine. 4 times 3 is 12. Carry the 1. We cannot write it as 12 over here. You always carry the tens in the next number. Then you do 4 times 1, that's 4, plus the 1, that's 5. So 52 is your value of x. That is the number of tens he had at the beginning of the day. So for these type of questions, you need to know how to translate the statement into an equation. Then we have sequences. For sequences, you need to see what is the common difference. Is the first difference common? If not, is the second difference common? If the first difference is common, that means the linear equation. That means a linear sequence. If the second difference is common, it's a quadratic sequence. If nothing is common and it's coming out as an exponent, then it's an exponential sequence, which is like over here. In part B, we know anything to the power of 0 is 1. So 5 to the power of 0. This is 5 to the power of 1. This is 5 square, 5 cube, 5 to the power of 4. So that means your nth term is going to be 5 to the power of n minus 1, because this is the first term. So in the power, n is your, what term it is? Is it the first term, second term, third term, fourth term? 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. So it's like that. This one, you see what is the common difference. 8 minus 11 is negative 3. 5 minus 8, negative 3. 2 minus 5, negative 3. So there's a common difference of negative 3. Whatever is the common difference, you will times it by n, and then see if we replace that with 1, 2, or 3, do we get the terms in the sequence or not? So with 1, negative 3 times 1 gives me negative 3, not 11. But we need an 11. So what do we add and subtract to negative 3 to get an 11? I'm going to add 14 to it, because 14 minus 3 is 11. So if we use negative 3n plus 14 as the nth term, second term is going to be negative 3 times 2 plus 14. That's negative 6 plus 14, and that is 8, which means your nth term is negative 3n plus 14. So for these type of questions, try to see if there's a common difference. If there's a common difference, multiply that by n, and then see what you can add or subtract to get the terms in the sequence. If there is no common difference, whether it's second or first, whether it's first or second, then you see whether it's an exponent. And that was in part B. It was the 5 times table. So that's how you solve your sequences questions, whether it's finding the nth term or the next term. We've already talked about the speed time graph. I told you for the acceleration or deceleration, you find the slope, and for the total distance, you find the area under the graph. So we have done that. Then explaining why a number is not a prime number, you need to see whether it comes in another times table or not. So 111 is in the 3 times table. How do I know that? It's because the divisibility rule for 3 is that if the numbers in a value add up to a number that comes in the 3 times table, then the number is also in the 3 times table. So since when I add 1, 1, and 1, that gives me 3. And I know 3 is in the 3 times table. So that means 111 is also going to be in the 3 times table. So let's see, if I divide 111 by 3, 3 threes are 9. 11 minus 9 is 2. Bring the 1 down. 3 sevens are 21. So yes, it is in the 3 times table and the 37 times table. So that's why 111 is not a prime number. If it was a prime number, it would only be in the 1 times table and the 111 times table. You need to know your divisibility rules as well, by the way. The divisibility rule for 9 is the same, that if the numbers add up to a number that comes in the 9 times table, then it is divisible by 9. For a number to be divisible by 5, it needs to end with the number 5 or 0. Then for a number to be divisible by 2, the last digit has to be even. For the number to be divisible by 4, the last 2 digits are supposed to be divisible by 4. So if it's like, a 2-digit number, so whether it's like, if it's like a 3-digit number, let's say, if the last 2 digits come in the 4 times table, then the entire number is divisible by 4. So for a number to be divisible by 6, it has to be divisible by 2 and 3 as well. So you can check whether it comes in the 2 times table and 3 times table. If it does, then it's also divisible by 6. Then for 10, we know that the number needs to end with a 0 for it to be divisible by 10. So these are the main divisibility rules that you need to be aware of. Then for bearing, I've already made a video on trigonometry and has questions on bearing. So I strongly recommend that you go to that video and develop better understanding about bearing. So that over here, I'll just give you like a quick idea of how to solve bearing. So in bearing, you need to realize that the knots for any 2 points are parallel. And when we have 2 parallel lines, alternate angles are equal. So which means if I just complete the compass over here, this angle is the same as this one because they are both alternate to each other. So they're asking about the bearing of Q from P. So Q from P means we're going to measure the angle at P. So we start from the north of P and go clockwise direction till the point where we reach the line that connects point Q with point P. So we need this angle. We already know that angles on a straight line are equal to 180, which means this part is equal to 180. And to find this part over here, we know that a quadrant is 90 degrees. A part of that quadrant is 39. So if we do 90 minus 39, that's 51 degrees. So this part over here is 51. So bearing is going to be the sum of 180 and 51, which equals to 231 degrees. So that's how you find the bearing. Your concept of alternate angles will always be used in bearings, like every single time. And also remember that the bearing is measured always in clockwise direction, never in anti-clockwise direction. The bearing is always written as a 3-digit number, not a 2-digit number or a 1-digit number. For example, the bearing is 9. So I will write it as 009, not 9. If it's 10, you will write it as 010, not just 10. So it's always written as a 3-digit number. It's always measured in the clockwise direction from the north. And from P means so when it says from some point,
you will draw the compass at that point and measure the angle from that point, like at that point, not at the other point. Then we already talked about metric conversions, but over there we talked about like going from a bigger to a smaller unit. Over here, they're talking about going from a smaller to a bigger unit. So we said that 1 kilometer is equal to 1,000,000 millimeters. So 1 millimeter is going to equal to 1 millionth of a kilometer. When you're going from a smaller to a bigger unit, we will divide. When it's bigger to a smaller, we times. That's why in that case, we multiply it by a million. Over here, we're going to divide by a million. So 62,000 divided by 1 million. We cancel out these three zeros with these three zeros. Leading zeros can be cancelled out, given that we cancel out the same number of zeros. So 3 from the above, 3 from the denominator. So that leaves us with 62 over 1,000. And we already said that if we're dividing by 1,000, every whole number has a decimal at its end. So we move the decimal 3 places to the left. So that's 0.062 kilometers. That's your answer. Then let's see if there's anything else. Rounding. Okay. So this is a very basic concept that you've done before. So let's recap this. Corrected two decimal places mean that we're talking about the two numbers after decimal, but the second number will be rounded based on the number in the third decimal place, which is 8 over here. So focus number is 24.078. So we will round 7 based on the third decimal, which is 8. So 8 is above 5, which means we will round 7 up. And when we round 7 up, that's going to be 24.08. If 8 was less than 5, let's say it was 3, then it would be 24.07. It will not change. So for rounding correct to the nearest 10, we need to see what is 24 between. So 24 is between 20 and 30 because we're talking about tens. So 24 is closer to 20 because it's less than 25. Since 24.07839 is closer to 20, that means rounded correct to the nearest 10 is going to be 20. If it was more than 25, then it would be 30. So it depends on the tens value because we're focusing on round to the nearest 10. So tens is going to be between 20 and 30. Then write down the number that is 9 greater than negative 23. So 9 greater than negative 23 means negative 23 plus 9. Like I mentioned earlier, when you're adding a negative integer to a positive integer, we will do 23 minus 9, which is 14. But the answer will have the sign of the bigger number, which is 23 over, so it's negative 14. So that's your answer. Then over here, like evaluating expressions, you just substitute the value. So v equals to 30 plus negative 2 times 7. We did talk about multiplying a negative with a positive integer. So negative 2 times positive 7 is going to be negative 14. 30 minus 14 is going to be 16. So simple as that. You just need to remember like what happens when you're adding negative integers, subtracting them, multiplying them, or dividing them. Then rearranging the formula. So for this, you need to know what is the opposite of what. So you know opposite of addition is subtraction, opposite of division is multiplication. But what is the opposite of a square root? Opposite of a square root is squaring something. So square root of x, opposite would be x squared. So in rearranging the formula, we are changing the subject of the equation. Over here, you can see that they're asking us to make d the subject. So to make d the subject, you have to make sure that d is isolated on one side. It's alone on one side. So for that, we have to get rid of the square root first. So to get rid of the square root, that means we will square d. Because when you take the square root on the other side, it does the opposite thing. Now over here, it's going to be 3d minus e. Then we take e to the other side, so it's going to be plus e now. opposite thing. And then we take 3 to the other side, it's going to be divided by 3 now. So when you move one thing from one side to the other side, it does the opposite. And you have to make sure that you find the value of the variable that they're talking about, not leave it at 3D. If you leave it at 3D, they will not give you full marks. You have to give the value of D. So you have to make sure that D is alone on one side. It doesn't have anything with it. Similarly, if it's cube root, opposite is x cube. So you need to be aware of this distinction. Then we've talked about percentages, we've talked about time, talked about reciprocal. For this question, you will first change the mixed number into an improper fraction, then flip it. Then symbols. This symbol means greater than. This is less than, and that's the equal to. So for these questions, you will turn the fractions into decimals and then compare like, which one is bigger or smaller. Make sure that when you're comparing them, both sides are need to be in the same format. Make both sides either into decimals, fractions, or percentages. That would be easier for you. And I want to talk about ratios. So some kids still confuse this thing. The question says Safia has a piece of fabric of length 5.6 meters. She cuts the fabric into two parts with lengths in the ratio 3:4. Calculate the length of the longer part. So to calculate the length of the longer part, first we need to create a fraction for the longer part. So to create a fraction from a ratio, first we add the values given the ratio. So 3 plus 4, that's 7. So for the longer part, denominator for the fraction is going to be the sum of the values in the ratio, so that's 7. And numerator will be the value for the longer part. Obviously, the longer part will have a bigger value. So 4 comes over here. So 4 over 7 is the fraction that we created for the longer part from the ratio. Always add the values for the denominator, and for the numerator, we take the value that is associated to that thing. So 4 over 7 is the fraction for longer part. And if the length is 5.6, you just times this by 5.6. So over here, we can rewrite the 5.6 as 56 over 10 because writing this as a fraction is easier. Then we can simplify. 56 and 7 comes in the same times table, so that's 8. 4 and 10 come in the 2 times table, so that's going to be 5 over here. So now we have 16 over 5. You can just divide 16 by 5. That's 3, 15, 1, 0, 2. So 3.2 meters is your answer. So I did several things in this question. First, created a fraction from the ratio. Then I converted the decimal into a fraction. Then I simplified the fractions because you're multiplying the fractions. And then at the end, I divide the numerator by the denominator to get the answer in decimals. So all of the skills used in one question. So you need to brush up on these skills. They're not that difficult. You've already learned these before. It's just that you haven't practiced these recently because you were dependent on the calculator. So you've forgotten them. But if you practice same questions, watch this video, do them again and again, like a few times, trust me, you would be remembering all of this again. Then for question 23, for these type of questions, you have to convert both the sides into the same format. Like over here, you expand the equation, simplify it, and then compare the same variables. Then compare like similar variables on each side to each other, and then find the values of the missing things. So for example, I expand x minus 5 square. So that's x minus 5 times x minus 5 plus k over here. X times x is x square. X times negative 5 is negative 5x. Again, negative 5 times x is negative 5x, and negative 5 times negative 5 is positive 20. Remember, two negative values getting multiplied give a positive answer. So over here we have x squared minus bx minus 21. So now we know for x squared, let me highlight, we have x squared and x squared. So they're already equal. There's no other variable attached to it. So we don't need to worry about this. This is negative 5x minus 5x, and this is negative px. So negative 5x minus 5x is negative 10x. So that is equal to negative px. You have to find the value of p. So x divided by x is 1. So negative divided by negative is also positive. So 10 equals to p. Simple as that. And for the constant, we know that 25 plus k and negative 21 are the constants. So 25 plus k is put equal to negative 21. K equals to negative 21 minus 25, and that's negative 46. So you don't have to solve like both sides with each other. They're saying this side is equal to the other side. So if they're equal, just convert them into the same format. Take the same things that are like, similar, like x squared equals to x squared, then the x equal to x, constant equal to constant, and then find the values of the missing variables. Then we already talked about difference of perfect squares, taking the highest common factor common. So I'm going to skip. Actually, for this, I think we should do this. So over here, we know that we can't do difference of perfect squares because 63 and 29, because 63 and 28 are not square numbers. But we can take the highest common factor common. We know 63 and 28 come in the 7 times table. So 7 bracket 9x squared minus 4y squared. Now, if you're wondering, we've already fully factorized it. That's incorrect. When it says factorize fully, that means there is more than one step. So 9x squared minus 4y squared, now it's difference of perfect squares. 9 is a square number, x is being squared, 4 is a square number, y is being squared. So it's going to be 3x minus 2y times 3x plus 2y. This is your fully factorized answer. If you would stop over here, you will not get full marks. And these are easy scoring marks. So just like make sure that you have fully factorized it. Just look at your answer again and see if there's anything that you can change. If you cannot, then you can move on to the next question. Then this one is also going to be a commonly occurring question. So obviously in P2, we cannot use the calculator. Since we cannot use the calculator, we cannot solve equations with pi. So what they would tell you is give your answer in terms of pi. So read the question carefully because some kids forget that and they just keep on getting confused and try to solve it for pi. You don't have to. If they say give your answer in terms of pi, leave it in terms of pi. Don't overcomplicate it for yourself. So it says points A, B, C, and D lie on a circle. A, B, C, D is a square with the area of 72. So this square has an area of 72. Now, what did we learn about the properties of a shape? We learned that a square has all equal sides. So if it has all equal sides, length times width is 72. So length times width is 72. And let's say the length and width are x. So x times x is 72. That's x squared. So opposite of square is square root. So x equals to square root of 72. Now I want to factorize the 72. So 72 is 9 times 8. 9 is 3 times 3. 8 is 4 times 2, and that's 2 times 2. So this is 3 square because we have two threes. 2 square times 2. The reason why I'm leaving 2 squares separate from 2 because we're going to take the square root. So I want to keep the squares separate. So 3 square is 9, square root of 9 is 3, so that comes outside. 2 square is 4, square root of 4 is 2, so the 2 comes outside. So that's 6 root 2. That is your dimension for the square. Now we know that D to B is your diameter, and half of the diameter is radius. So if x is 6 root 2, and we have a right angle triangle because a square is a right angle, so we can use Pythagoras over here. So based on Pythagoras, your hypotenuse square, so D squared equals to 6 root 2 squared plus 6 root 2 squared. 6 root 2 square is 72, and then again plus 72. That's d square. Because 6 square is 36, 36 times 2 is 72. So we add the 72s, that's going to be 144. D equals to square root of 144, and that is 12, which means the radius is going to be 6. Now, area of circle is going to be pi times 6 squared, which is 36 pi. That is it. It says give your answer as a multiple of pi, so this is the multiple of pi. Pi is getting multiplied to 36, so it's a multiple. So 36 pi is the area. So just read the question carefully and follow what they're telling you to do. Don't start to overcomplicate it. They would not give you a difficult calculation in paper 2 because they know you can't use the calculator. So everything that they will give you can be solved mentally. Then this thing, okay, so convert 7.51 meters square into centimeter square. A lot of kids make this mistake that they think that, 1 meter is 100 centimeters. So if it says 1 meter square, they do 2 times 100, and that's 200 centimeters. They think this is 1 meter square equal to. That's incorrect. If 1 meter is 100 centimeters, 1 meter square is 1 meter times 1 meter, which is going to be 100 centimeters times 100 centimeters. So 1 meter square is equal to 10,000 centimeters square. You multiply the 100 to the 100 because it's meter square. So meter times meter is meter square. So centimeters times centimeter is going to be centimeter square. So you multiply them. So 7.51 times 10,000 means that we're moving the decimal 4 places to the right. That's 75100 meter centimeter square. So remember, if they're adding a power to the metric unit, you will multiply it by that thing like that many times. If it's square, you multiply it 2 times. If it's cube, you multiply it 3 times. So make sure to not make this mistake. This is very easy. Like again, easy scoring marks that you can score to improve your grade. Then we already talked about natural numbers, irrational numbers, and reciprocals. Natural numbers are numbers starting from 1. Irrational numbers are number that cannot be converted into a fraction. Reciprocal of 4 is going to be you flip 4, that is 1 over 4. So over here, this is your 0.25, that's reciprocal of 4. The reason why I'm not choosing negative 1 over 4 because in reciprocal, we don't change the sign. We just flip it. 1 over 4 is the same as 0.25. So you need to know this as well. Yeah, I forgot about that. 3 over 4 is 0.75. 1 over 4 is 0.25. 1 over 2 is 0.5. You need to know about these things as well so that you can easily do the calculation. Irrational number over here is going to be root 3. Root numbers are like always irrational numbers unless like you can solve it. And natural number, it has to be, what's it called? A whole number, but it cannot be negative. So that's going to be 24. Then we've talked about sequences. We've talked about rearranging, like once again, there's cube root over here. So it will be v cube when we get rid of the cube root. So v cube equals to x over y, and then v cube times y equals to x. So this is x in terms of v and y. Then for this one, Sasha buys B books and M magazines. The cost of each book is $12 and the cost of each magazine is $5. Write an expression in terms of B and M for the total cost of the books and magazines. So if the cost of each book is 12 for B books, it's going to be 12 times B. And the cost of each magazine is 5, so it's going to be 5 times M. And since talking about the total cost, you add it up. So 12B plus 5M. Forming expressions is very easy. You just have to translate the statement into an equation. So this is similar to what we did previously for, I think, the fraction question, yeah. So just read the statement carefully, rewrite it as an equation. Simple as that. Then we've already talked about this, like for division, you will keep the first fraction as it is. Change division to times and then flip the second fraction and simplify. Fractions with unlike denominators, if you're adding them or subtracting them, you have to make the denominators equal. Before I end the video, I want to talk about a few topics really quickly. So we talk about types of correlation. So if your data set is like this, like, all of the values are like this, that's positive correlation. In positive correlation, if one thing is increasing, the other is also increasing. In negative correlation, it's it's going to be a negative slope. So it's going to be like this. If one thing increases, the other decreases, and vice versa. And then there's no correlation. So they're all scattered. So both the values are not impacting each other. So the types of correlation, then I want to talk about probability. So if the probability of something happening is, let's say, probability of getting a red is 4 over 7, let's say. So probability of red not happening is going to be 1 minus 4 over 7, that's 3 over 7. You will always do this. If you have the probability of something happening, so to find the probability of that thing not happening, you just subtract the probability from 1, whether it's a fraction or a decimal. If it's like in terms of percentages, then you subtract it. Then you subtract it from 100. But if it's decimals or percentage, you will always subtract it from 1 to find the probability of that event not happening. So that, and apart from that, I want to talk about the different types of graphs. Yes. So the different types of graph, we know this is a quadratic graph. If it's a U, it's a quadratic. This is your minimum quadratic. That is your maximum quadratic. Then this is your cubic graph. This is also cubic. This is with a negative coefficient of x cubed. This is with positive. Then we know a linear graph is a straight graph. Apart from that, I've already talked about your sine, cos, and tan graphs in a separate video, which you can check out from the playlist for all of topics for IGCSE. The reciprocal one, yes. This is your reciprocal graph. This is when your numerator is positive. So let's say y to 2 or x. So if it's positive, it's going to be this. And if it's negative, I'm using a different color for that. That's going to be this. So we have a reciprocal graph, we have cubic, quadratic, linear. I think we've covered all of the graphs that you can be tested on. Yeah. And with that, I think I've covered everything that you need to know for paper 2. If you still have any questions or confusions, please leave a comment below and I'll help you out. If you understood everything, please like and subscribe, share this video with your friends. And don't forget to check out the other videos in this playlist because I think this video is greatly going to help you because I've combined everything that I've come across paper 2 from 2023 to 2025. Obviously, the 2023 and 2024 questions were not calculator free questions, but I still chose the ones that can be easily come in the upcoming exams. So do practice these. I'm attaching the document link in the description as well. Practice these on your own as well. And if you still get somewhere, reach out to me in the comments below.